So today we're going to actually start with just some vocab from the past, just to make sure that you're fresh with that. Then I'm going to talk about some end behavior stuff, and then I'm going to show you a skill that combines synthetic division with factoring. So first term I want to go over is what leading coefficient is. That is the number that is in front of the letter who has the biggest exponent. In other words, when you put your answers in order for me, kind of like we've been doing all school year, where you put like the x squared first and then the x and then the number, whatever is out in front of all of that, that's called the leading coefficient because it's obviously leading the charge. Degree would be the biggest exponent in the problem, and it's always going to be attached to a letter. So like x cubed, x squared, x to the fourth, you take the biggest of them. And then standard form is when you put it in order, descending order based on exponents. And that's something that I've been having you do with various problems. So like we would put x to the fourth and then x cubed, x squared, x, and then a number. That's called standard form. So we have some names based on certain degrees. The first one is if you have something of degree 0, that is called a constant function, and that's the formula, that's a sample problem. That would be a function. So you can see that you have no letter in here. That is the same thing as writing x to the 0. So if you have x to the 0, that's actually just 1, and 3 times 1 is 3. So a lot of times kids are like, well, there is no letter. Well, there is. It's x to the 0, and we don't bother writing that. So you have graphed these in the past. You graphed them in Algebra 1. Those are your horizontal lines. So those are actually called constant functions. If your degree is 1, then that is called a linear function. So if you have an x in the problem, it's either going to be a diagonal line or it's going to be straight up and down. That is what we call linear. And that could be something like 2x plus 8. Just have to remember there is a 1 right here. It's technically x to the first, so that's where the 1 comes from. If your degree is 2, it is called a quadratic function, and you have done lots of these this school year for me. For example, if I have x squared plus 4x, even though this has x to the first in it, the bigger exponent wins the game, so we go with the 2 and name it quadratic. If your degree is 3, that's called cubic. And here's an example of a cubic polynomial. So even though it has an x squared in it, 3 is more than 2. So 3 wins. We use him to name the function. So it is a cubic function. And then last but not least, if your degree is 4, that is called a quartic polynomial. So for example, if I had x squared plus 3x to the fourth, that would be quartic. Even though there's an x squared in it, 4 is more than 2, so therefore we go by the 4. 4 is the degree. Now anything that's higher than 4, we typically just say polynomial of degree 5, polynomial of degree 6, polynomial of degree 7, and so on. We just have names for these because most often, like, our problems will be either 0 through 4 in terms of their exponents. We don't go above that a lot, so that's why we just have names for those ones. So I'd like to do one example with you, and then I think you could actually try the other 3 on your own. But we're going to take each polynomial and we're going to put it in standard form. We're going to identify the degree, the type, and then the leading coefficient. So I think it's a good idea when you're asked to give a lot of information if you just make a list. There's your standard form, your degree, your type, and your leading coefficient. So if I was you, I would just go ahead and do that for all of them so that you're set up, and then all you have to do is just identify information. All right, so standard form, I have to put the highest exponent first. So the 5 goes first, and then the -2, and then the 8. So we want these going down, which they are, so that's good. And then my degree would be 3 because that is the largest exponent. And we talked about in our chart, if it's degree 3, it's called a cubic function. And because it's in order, all I have to do is look at the front for the leading coefficient, and that is 5. So because this isn't like super complicated, you're not actually doing any work, you're just following rules of definitions, I'm going to say go ahead and pause the video and try these on your own, and when you're ready you can unpause and we'll see if our answers match. All right, go ahead and check it out. See if you have the same order that I have here. I made sure to throw in a quartic, a quadratic, and a linear example, so you kind of had one of each there. And then just check those leading coefficients and etc. The next thing I want to move into is what is called end behavior. So here's the term for it. We say, what's going on as x approaches infinity and negative infinity? Now, you'll get more accustomed to that language if you take pre-calc and calc especially, calc 1. But if you don't, all you need to know is that when you're talking about x's, infinity means the right side and negative means the left side. So end behavior is just telling me what's going on the right end and the left end of the graph. How are those arrows? Are they pointing up? Or are they pointing down, or what? So you can actually tell me what the end behavior is of a graph. You can actually form a picture of the graph just from knowing its degree and the sign of the leading coefficient. If you have that information, then you can predict what the picture is going to look like, and thus you'll know the end behavior. So there's 4 scenarios that are possible. Either your degree is even or it's odd. It's one or the other. And if it's even, it's either has a positive leading coefficient or negative. And same thing if it's odd, either the leading coefficient's positive or it's negative. So every problem you get is going to be one of these 4 situations. So I'm going to start out with my evens. If you have a positive coefficient, so what I did is I actually graphed this function in Desmos. This is the picture of it. And you can see it looks a little wonky in the middle. Okay, that's the kind of stuff that happens when you have these higher powers. But if you remember when we graphed x squared, it was just a smiley face, right? It's going to be the same thing for any even power. It doesn't matter if it's like x to the 4th, 6th, 8th, 10th, whatever. If it's an even degree, it's going to resemble a smiley face. And you can see that here. This is still overall smiling. It's just doing some weird stuff in the middle. Well, we don't really care about the middle in Algebra 2. We only care about the ends. Now, Desmos does not draw arrows, so you have to kind of visualize your own arrows in these pictures. If that's something that's going to bother you, then go ahead and fill them in. But there's always arrows pointing so that the graph can continue to go the way it's supposed to go. All right. So let's just take a minute to just think about what's going on. So if you look at the right side of this smiley face, that would be right here, right? That's the right end. And I just want to know, is that arrow pointing up or down? Then hopefully you're like, oh, it's pointing upwards. Then I'm going to say, well, what's going on the left end? And you're going to say, oh, that arrow is still pointing upwards. So you need a way to present that information to me. So like everything else in math, we're lazy. We don't like to write a lot of words. We like symbols. So the first thing you're going to write is as x approaches, this arrow means the word approaches, infinity. As x approaches infinity, that means on the right end over here. Then you're going to finish with f of x also approaches infinity. As x approaches infinity, f of x approaches infinity. Remember that f of x is the same thing as y, and y pertains to height. So it means the height is going up on the right side of the graph. So if we look on the right side, the arrow is pointing up. That's what that means. Now we covered the right side, we got to also cover the left side. So instead of infinity, you would say negative infinity, and that means the left side of the graph. So as x approaches the left side, or negative infinity, the arrow still points upwards towards positive infinity. So this would be like looking left and right, and this would be your up or down arrows. Obviously, up means positive and down means negative infinity. So everything that we write here is going to follow this kind of setup. So our next formula, and this is the actual formula of this picture, you can see it's kind of weird here in the middle, but it is overall a frowny face. It's going down forever. So I'm going to start the same way because every graph has a right side and a left side. So tell me about the right side. As we look to the right, the arrow points down. As we look to the left, the arrow still points down. So you want to notice when your exponent's even, you're going to have the same end behavior. Either it's going to be smiley, so both pointing up, or it's going to be a frowny, where both are pointing down. But no matter what, you're going to start out the same way. Every graph has a right side, every graph has a left side. All right, so then let's look at what the odds are. So this is the graph of x to the 5th plus 2. And again, it doesn't matter if I have like x to the 3rd, x to the 5th, x to the 7th, whatever. It's going to resemble this picture. You're going to have an arrow pointing up, and you're going to have an arrow on the left pointing down. So on the right side of the picture, on the right side, you can see the arrow points up. So therefore, we're going to use positive infinity. And on the left side, the arrow points down. So we use negative infinity. Right? If we have a negative leading coefficient, that is going to spin around. So it's going to be the opposite. On the right side of the graph, right, positive infinity on the right side, the arrow points down. On the left side of the graph, the arrow points up. So you notice how you have, as x approaches infinity, f of x approaches. You have that in every single line. So you're going to set these all up the same way. So it's really, what are you putting on the end here? Does the arrow point up or down? So it's not too hard to do. I think it's just the notation of writing it sometimes intimidates kids. All right. So in my next video, I'm going to give you 4 examples, and we're going to see if we can figure out, 1, what the picture even looks like, and then 2, how do we write the end behavior.